So in this video, I have this compound inequality, and I need to solve for n. So let's do that. There's actually two ways that I can do this. So ways, and there's two. So I'm going to have two branches here. Way 1 and way 2. So way 1 is just leaving it the way it is, and then solving. Now remember I was talking about how when you have two sides, you got to do what you do on one side to the other side. Here you actually have kind of three sides, right? Three different sides. So what you do in the middle, you have to do to both of the sides, essentially, in this case. So if I subtract 9 from both sides, or all the sides here, and I guess you have only two sides, and this is in the middle, but yeah, anyway, so you have to do it everywhere. So negative 6 minus 9 is just negative 15. Negative 15 is less than 3n is less than 21 minus 9. What is 21 minus 9? 21 minus 10 is 11, so 21 minus 9 is 12. Because you're subtracting one less, right? So yeah, 21 minus 9 is 12. That's it. And then you can divide by 3, both sides. You're not dividing by a negative number, so you don't have to flip the signs. Although you would have to if you were dividing by a negative number. This would be negative 5 is less than n is less than 12 divided by 3, which is 4. This would be your answer. If you wanted to put the greatest number first, that would just be 4 is greater than n, or n is less than 4, and then n is greater than negative 5. This would be another valid way. So both of these are valid, right? These are the two answers. Two answers. If you were asked, interpret these answers in context or something like that, and not in context, interpret these answers, then essentially what you would say is that n can be between negative 5 and 4, and when you put it into this equation, any of these numbers between negative 5 and 4 non-inclusive, which means not including negative 5 and 4, then you would have an equation that is, or an inequality that is satisfied, right? So everything would be satisfied. We'll actually try once we solve this. This should produce the same exact result. In fact, I like way 1 better because it's faster in the sense that you don't need to convert it back to this form. If it was in the and form originally, then maybe way 2 would be better because you might need to keep it in the and form. But if it's in this form, in the problem, and then just you solve it in this form, you keep it in this form, this is just faster. So let's do way 2. So way 2 is actually not leaving it in this form, but actually rewriting it. Let's just split it into 2. So negative 6 is less than 3n plus 9. And then also 21 is greater than 3n plus 9. This is the same exact thing that we did here. Notice, we're doing the same exact thing, except here we did it all at once. We did since 3n plus 9 and 3n plus 9 are the same thing, we're doing the same steps, essentially. Except here, we didn't split it up like we're doing here, and then doing it separately, but like we're doing it here just together, right? And this is actually faster. You don't need to do this extra step of splitting it up, especially if the problem didn't have it split up. As I said before. So here we have this one. Let's do this one first. Negative 6 is less than 3n plus 9. We actually did that on this side. Subtract n, negative 15, 3n, divide by 3. Negative 5 is less than n. We have this portion now. And then now here we can subtract n. Again, 12 is greater than 3n, and then n is less than 4. So this is it. Now we would need to convert it back to a form like this, and of course we have our ands. We have our and, and I'll just try to fit it in here. And actually, I just rewrote this. I just realized I rewrote it. So yeah, that's and so if we wanted to write it in a form like this that we had originally in our problem, we would combine it. So this is just going to be negative 5 is less than n is less than 4. Okay. And then we can write the biggest number first if you wanted to. 4 is greater than n is greater than negative 5. And this is the same answer. Same to, I guess, 3. You could say 3 answers. 3 answers. They say the same exact thing, so they're not They're not different. Any of these would be acceptable on an exam, unless they specified specifically to write it in a certain form. Anyway, I hope you found this video helpful. I just realized that I need to check, right? I said I would check. Let's do our check step in between here. It's like a pyramid. So let's do our check step in between. So let me just do one number, and let's do 1. So -6 is less than 3 times 1. If everything went well, then this should satisfy. Less than 21. 3 plus 9 is 10, 11, 12, 12. 12 this. So both of these should satisfy. If you can't see it immediately, you can actually split it up. You can split it up. This, and let me write it out. I'll write it out in case you don't know what that sign is, but 12 is less than 21. Are both of these true? Is -6 less than 12? Yeah, because it's more left on the number line. It is less than 12. So yes, this is true. Is 12 less than 21? Yeah, this is also more left on the number line. It's true. So this is true. This is true. And it should be true. Every number here, even the decimal points, everything should satisfy this inequality. I hope you found this video helpful. I will be doing more examples.